Okay, ladies and gentlemen, we're going to talk about how to use the while loop. And I wrote a function to do it. The way this function works is that we're going to find the nth root of y. Here's y, here's n for the nth root. We're also going to tell it a precision, a small number. How precise do we want our answer? Because this is a successive approximation. We initialize, just make two guesses, x old and x new. The reason they're different is right here. Because if the difference between them is big, we want to go into our while loop. If the difference between them is small, we want to end. So when the difference divided by the sum is greater than the precision, and the absolute value of the difference is greater than divided by the sum is greater than the precision, then we're done. I'm going to put a counter in here too, just to see how many times we execute the while loop. And here's incrementing the counter. Now, the way we use while loops is we have an old value. So the new value, once we're done with the while loop, the new value becomes the new old value. And we calculate a new value. This is the Newton's root successive approximation to an nth root. What it does, it takes x old and y old. So y old equals x old to the nth power. And it fits a straight line to those 2 points. And then we make y equals mx plus b of that old line, y equals mx plus b, and using the x new. So we solve for, let me write that down as a comment. I'll solve for x new, solves y equals m slope old, LD, times x new plus b old for x new. So that's the way Newton's root works. I'm not going to go through all the theory. This is the formula. When you solve for this x new, you get this formula. You get an equation in terms of y, your input variable, what you're trying to find the nth root of, and what your old estimate was. And n. Okay. Then when the difference between these two becomes small enough, when it gets tiny, we say, okay, we found an approximation, a really good approximation. So let's go see how this works. I better save my function. There it is. There we go. Let's see. I want to find how many times it goes through. So I'm going to set this. Find nth root of, well, let's get the square root of 5. That's pretty easy. And I'm going to put in a precision, a small number, e minus 10. It converges really fast, as you can see. It only went through the while loop 4 times. Let's make it a lower precision, like 5. Oops. See how that works out. It only went through it 3 times if my precision is lower. Let's find the cubed root. Or first of all, before I go very much further, let's do square root. Let's use the built-in function to find the square root of 5. Let's see, we're really close. So up to here, right up to here, 2.236067, 2.236067. 606.797. Oh, we're even good to the 67977. So we're good up to this point. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9-digit accuracy, even though we only call for a 5-digit precision. So yeah, very, very close. Faster. If you don't need it as precise, you save time. This is a really fast converging algorithm anyway. And just for grins, let's find the, we did find the cube root. Let's find the cube root. Cube root of 5. And there is a function in MATLAB that can do this, nth root of 5, and we want to find the cube root. So this is how computer developers, somewhere buried in the operating system somewhere, is an algorithm like this. So this is how computer, way down buried deep in the operating system, in the compiler, in the interpreter, in Java, you have an algorithm a bit like this to calculate nth roots of numbers. It keeps going until it's small enough. It doesn't go for a set number of times like a for loop does. It keeps going to the end of some condition. It asks, is this condition true? So here's the condition for this. So that's how a while loop works. Note you have to initialize. And these two values have to be different so that when you're testing your condition, you're guaranteed to go into the while loop at least once. You could set these both to the same value, but it'd never go through the while loop. So this forces it to go through at least once. That's the purpose of the big difference. So it forces it to go into the while loop at least once. You're forcing the new value to be bigger than the precision of the old value. You could always go x new equals x old plus precision. That wouldn't be a bad way to do it. You got to set, you're going to get a new value. So the old value is the old new value, if that makes sense. Then you update your variable, the new value. Now x old and x new are different again. This was the previous estimate, x old. This is the new estimate. Then we can do the test again. It goes to the end of the while loop. At the beginning, it does the test again. And then it says, should we keep going? Are we precise enough? No, we're not. Let's keep going. And it keeps going until it's precise enough and then spits out an answer. Okay, that's a while loop. And that is the end of all the MATLAB I'm going to discuss for the semester. And I'm going to be sure and post up practice exams so you guys can get some experience with an exam much like the MATLAB exam you're going to see on the final. I urge you to do the practice exams and get a hold of me in my office hours too, my virtual office hours, obviously, but get a hold of me there too. Okay, so with that, best wishes, ladies and gentlemen, and I hope to see you later.